Welcome back. It is early 2026. Look at the device in your hand. Look at the headlines on your screen. You feel it, don't you? That slight hesitation in your AI assistant. The skyrocketing prices of cloud subscriptions. The sudden, inexplicable delays in flagship smartphone shipments. We were promised that 2026 would be the year artificial intelligence achieved God, like speed. Instead, the global digital economy is currently hitting a wall of concrete and silicon. Most analysts are telling you this is a temporary supply glitch. They are lying, or they simply don't understand the gravity of the situation. We are not facing a glitch. We are facing a systemic cardiac arrest of the modern world. The narrative you've been sold is that demand is simply too high, but the reality is far more terrifying. Our entire civilization has bet its future on a single island, sitting on a geopolitical fault line that is currently choking on its own success. While the world watches the Taiwan Strait with bated breath, fearing a military blockade. The blockade has already begun. It isn't made of warships, it is made of physics, yield rates, and a catastrophic shortage of high-bandwidth memory. But here's the twist that no one is talking about. This crisis, this nightmare of 2026, is actually a meticulously calculated trap. And the entity that seems most vulnerable right now might actually be holding the detonator that forces the rest of the world to finally grow up. Today, we dismantle the illusion of the AI revolution and expose the brutal industrial war happening in the shadows. To understand why your internet is getting expensive and why Wall Street is trembling, we need to strip away the marketing buzzwords and look at the industrial blood that keeps the system alive. Right now, virtually every major AI system, from the latest iteration of ChatGPT to Google's most advanced Gemini models, lives or dies based on chips manufactured by one single company, Taiwan Semiconductor Manufacturing Company, or TSMC. Let me give you the numbers that should keep you up at night. As we speak in 2026, TSMC controls approximately 92% of the world's most advanced logic chip manufacturing. We are talking about the 3 nanometer and 2 nanometer nodes. These are not just computer parts. They are the fundamental atomic structures required to process the massive datasets of modern AI. If you want to train a frontier model, you need NVIDIA's Blackwell or Rubin architecture GPUs. And NVIDIA cannot make them. They can only design them. Only TSMC can forge them. The demand for these AI chips has grown by 44.6% year over year. Yet TSMC's capacity has effectively hit a ceiling. We are seeing a utilization rate of over 100%. Every single wafer is spoken for before it is even polished. This isn't just a monopoly, it is a single point of failure for human intelligence. Imagine if 92% of the world's oil came from a single port, and that port was located in the most contested body of water on Earth. That is the reality of the semiconductor industry today. The terrifying part isn't just the bottleneck, it is the fragility. One earthquake, one power grid failure, or one naval blockade. And the global AI revolution doesn't just slow down, it stops dead. The silence you hear in the tech sector right now is the sound of $1 trillion of capital holding its breath. But we have been here before, haven't we? History has a cruel way of repeating itself when we refuse to learn the lesson. Let's rewind the clock. Do you remember the chaos of 2020 and 2021? The COVID-19 pandemic triggered a supply chain collapse that left thousands of unfinished cars rotting in parking lots because they lacked 50-cent microcontrollers. We saw what happens when just-in-time efficiency meets a black swan event. The world screamed, never again. Governments passed the CHIPS Act. Subsidies flowed like water. Yet, here we are in 2026, staring down the barrel of a crisis that makes the 2021 shortage look like a minor inconvenience. Back then, it was about seat warmers and game consoles. Today, it is about national security and the fundamental infrastructure of the internet. The opponent, in this case the geopolitical rival threatening the island, has watched this play out. They saw how a simple virus could cripple Western industry. Now, they don't need a virus, they just need to exert pressure. The boomerang effect here is critical to understand. In the past, when the West imposed sanctions or export controls to choke off the rival's access to chips, we assumed it would cripple them. Instead, look at what happened. It forced them to innovate. It forced them to build a shadow supply chain. And now, while we are still addicted to TSMC's efficiency, the rival has been quietly hardening their internal economy. We thought we were besieging a castle, only to realize we had locked ourselves inside our own fortress without enough food. The very strategy of concentrating production in Taiwan for economic efficiency has now become our greatest strategic liability. We optimized for profit and sacrificed survival. Why did we let this happen? Why did the smartest people in Silicon Valley, the trillion-dollar hyperscalers like Microsoft, Amazon, and Google, allow themselves to walk into this trap? To understand the opponent, or in this case, the collective blindness of the Western market, we have to look at the psychology of the software mindset. For the last 2 decades, the tech industry has operated on the belief that code is king and hardware is a commodity. Executives believed that if you threw enough money at a problem, the physics would bend. They treated fabs like utility companies, turn the tap, and the water flows. They forgot that building a semiconductor fab is the most complex engineering feat in human history. It takes 4 years and $20 billion to build a shell, and another 2 years to yield perfectly. There is an organizational memory gap. The current generation of CEOs has never managed a hardware crisis. They are used to scaling servers with a click of a button on AWS. They assumed TSMC would always be there, effectively outsourcing their survival instinct to a third party. They ignored the geopolitical chessboard because it was inefficient to worry about war. This cognitive dissonance, the refusal to accept that the digital world relies on physical, vulnerable locations, is why the shock of 2026 is hitting so hard. They are playing poker, thinking they can bluff physics. However, the story doesn't end with us helpless. The West has a card to play, a counter-strike mechanism that is often misunderstood. The bottleneck in 2026 isn't actually just the silicon wafer itself, it is the packaging. This is where the technical nuance becomes a strategic weapon. You see, an AI chip isn't just one slice of silicon. It is a complex sandwich of logic and memory, stitched together using a process called CoWoS. Think of the logic chip as a high-speed printing press, but a printing press is useless without paper and ink. In this analogy, the ink is HBM, high bandwidth memory. Right now, there is a massive global shortage of HBM, specifically the new HBM4 standard required for the latest models. This is where the tool vs product distinction becomes our ace in the hole. While TSMC manufactures the final product, the tools required to perform this advanced packaging, the literal machines that stack these chips with atomic precision, are overwhelmingly controlled by American, Dutch, and Japanese companies. Applied Materials, Lam Research, Clail, and BZ. We don't just own the oil, we own the rig that drills it. Even if a rival were to seize the foundries in Taiwan tomorrow, they would find themselves in possession of the world's most expensive paperweights within months. Without the constant stream of spare parts, software updates, and chemicals from the Western Alliance, those fabs stop working. It's like stealing a Ferrari but not having the keys or the fuel. The rival knows this. This technical dependency is the invisible wire tripping up any military ambition. We have weaponized the supply chain bottlenecks. This leads us to a state of symmetrical monopoly. It is a tense, dangerous standoff, but it is stable. We need to visualize this clearly. On one side of the scale, you have Taiwan and TSMC holding the physical production capacity, the 92% market share of the actual chip fabrication. That is a massive weight. But on the other side of the scale, the United States and its allies hold 90% of the market for electronic design automation, EDA software, the cadence and synopsis tools without which you cannot design a chip. We hold over 80% of the critical equipment market. The rival cannot move without our tools. We cannot compute without their fabs. It is a classic, mutually assured economic destruction. The narrative that the West is purely a victim is false. We are a victim of our own outsourcing, yes, but we still hold the master keys to the factory. This symmetry is the only thing preventing a hot war in 2026. Both sides have a gun to the other's head. The problem is, in 2026, the gun is getting heavy and someone's hand is shaking. The market is realizing that this symmetry doesn't guarantee supply. It only guarantees that if one goes down, everyone goes down. It's a suicide pact masquerading as a supply chain. Let's run the simulation. What happens if this pact breaks? We don't have to guess. We can look at third-party casualties. Look at what happened to the Russian tech sector post-2022, or the stagnation in certain sanctioned industries. They didn't collapse overnight, but they began a slow, agonizing regression. Now scale that up. If TSMC stumbles, due to a blockade, an accident, or sabotage, the shockwave hits immediately. In the first 48 hours, global tech stocks would shed roughly $2 trillion. Within a month, the production lines of Apple, Nevada IDEA, and AMD would halt. But the real pain comes in the secondary markets. Cloud computing costs would triple. The automotive industry, which just recovered, would shut down again. We are looking at a global depression triggered not by banks, but by sand. This isn't fear, mongering, it is the mathematical certainty of our current inventory levels. The just-in-time inventory of high-end AI chips is effectively zero. We are running on fumes. The realization of this vulnerability is what is driving the frantic, panic buying behavior we see from hyperscalers in Q1 of 2026. They are hoarding chips like toilet paper, which only accelerates the shortage. This brings us to the concept of deterrence. In international relations, there is a theory that possessing a weapon is most effective when you never use it. The Silicon Shield of Taiwan was supposed to be this deterrent, the idea that the world would defend the island because it is indispensable. But in 2026, we are seeing the flip side, the silicon hostage. The reliance is so high that it incentivizes the rival to threaten the supply just to gain leverage in other areas. However, the Western strategy of strategic restraint is in play. We are not cutting off all trade, we are managing the flow. By keeping the rival dependent on legacy chips and allowing limited access, we reduce their incentive to flip the table completely. It is a delicate balance of strangulation and breathing room. We are using the chip supply as a thermostat for geopolitical tension, dialing it down when things get too hot, and dialing it up when we need leverage. It is a dangerous game, but it is the only one we have until the cavalry arrives. And the cavalry is arriving. This is the ultimate solution, and the reason why the nightmare of 2026 is an inflection point, not an apocalypse. For years, we heard promises about diversification. Now, in 2026, we are seeing the steel in the ground. Intel's massive $100 billion bet on the IDM 2.0 strategy is finally bearing fruit. The Ohio and Arizona fabs are coming online with the 18A process node. It has been a long, painful road for Intel, plagued by delays and skepticism. But the timeline is converging. By the end of this year, we will see the first major AI accelerators rolling off American assembly lines. It won't replace TSMC overnight, nothing can, but it breaks the psychological stranglehold. AWS has partnered with alternative foundries. Samsung is stabilizing its yield. We are witnessing the birth of a distributed foundry network. We are moving from a centralized model, where all roads lead to Hsinchu, to a decentralized model with nodes in Germany, Japan, and the United States. Furthermore, new technologies like optical interconnects and glass substrates are changing the game, allowing us to bypass some of the bottlenecks that TSMC currently monopolizes. The monopoly is being eroded not by force, but by innovation and capital. So let's tally the bill. What is the cost of this transition? It is enormous. We are effectively duplicating the most expensive infrastructure on Earth. The era of cheap electronics is over. The deflationary force of globalization is being replaced by the inflationary force of resilience. Your iPhone will cost more. Your cloud subscription will cost more. But this is the insurance premium we must pay for national survival. The history of economics teaches us that monopolies eventually rot from within or are dismantled by external shocks. TSMC is an incredible company, a miracle of engineering, but the world cannot tolerate a single point of failure forever. The pain we are feeling in 2026 is the growing pain of a new industrial order. We are trading efficiency for security. It is a bad deal for your wallet in the short term, but a necessary deal for the stability of the future. The rival's strategy of intimidation has backfired. Instead of submitting, the world has decided to build its own boats. What does this mean for you? Watching this in your living room, it means the technology you use every day is about to become a battleground. It means that the AI revolution will be uneven. There will be haves and have-nots, nations that have secured their silicon supply lines and those that haven't. For the investor, it means looking beyond the obvious names. The real value for the next decade isn't just in the chip designers, but in the companies that build the infrastructure of independence, the energy providers, the material scientists, the domestic fabricators. We are witnessing the shift from the information age to the material age. We realize that you cannot eat software. You need the hardware to run it. This leaves us with a choice. We can panic about the shortage, or we can recognize it for what it is. The signal to adapt. 2026 is the year the world wakes up. The nightmare scenario is unfolding, yes, but the dawn is visible on the horizon. The question is no longer, what if TSMC stumbles? The question is, what are we building to ensure it doesn't matter if they do? I want to hear your take. Do you think the US and its allies can build independence fast enough? Or will the supply chain snap before the new fabs are ready? Are you willing to pay 20% more for your electronics to ensure they aren't held hostage? Let me know in the comments below. And as always, stay critical, stay informed.